Right, so my name is Pieter. I had this idea to maybe have a special session on coastal forest conservation, just to get an idea of all the research that's been done on coastal forests. What do we know so far? And that all of us that work together on this can maybe say, what do we still need to know? And how can that be implemented? So after this morning session, when we talk about this, the implementation gap or the implementation space, I thought that's what we're going to come up with. But just coming out of the discussion on the eThekwini municipality, it seems that our research that we do can actually be implemented, and that's a real positive. Right, so coastal forests used to be more widespread than what are today. So this is just a quote of a certain Mr. Frederick Krauss that described Durban in the 1800s. And he said that along the coast, as well as inland in the gorges between the mountains, were wide forests with enormous trees. These forests could only be entered along the elephant paths, but not safely without a gun, in case one of these glossy passed by. So you can imagine that this landscape used to look a lot different. Massive trees around Durban, estuaries, grasslands, woodlands. But this is more what we find today. So instead of grasslands, woodlands, and forests, we have sugarcane plantations, we have urban developments, we have rural settlements, we have plantations. And just here along the gorges, but randomly distributed, we have some natural habitats and some forest left. So how do species respond to land use change at such a scale? So the first question that I asked myself, or before we could start to answer that question, is how much forest did we really lost? How was this landscape transformed? Can we quantify it? And unlike certain areas in North America and Europe, in South Africa we don't really have a time series of data that we can say this is how natural habitat changed. So what I did was I developed a species distribution model, and I asked where is conditions suitable for forest based on where forests are today, and then what habitats are there at those locations now. Is it forest? Is it something else? I looked at 3 different forest types that we found here on the coastal plain: lowland forest, swamp forest, and dune forest. And what I found was that 83% or 87% of area that is suitable for forest is not actually occupied by forest. If you look a bit finer, you can see that not all of that is transformed. Most of it is. However, some of it's also woodland and grassland. If we then assume that we have lost 87% of forest, that means that this area now harbors an extinction debt. So extinction debt is all the future species losses that we will incur based on past habitat losses. If I then model this extinction debt, it comes up at 14 bird species. So I specifically look at birds. And this number 14 closely matched the number of locally threatened species and the 3 regional threatened species. So then we can assume that threatened species make up this debt. The next question then that we have to ask is, how should we invest conservation resources if we want to restore this landscape and prevent these predicted extinctions? And I suggest to answer this question, we break it up into 3 sub-questions. First, we find out where are species going extinct. So where are we at this stage losing species? Second, we want to know which species are likely to go extinct. So we want to put a name to the extinction debt. So even though it compares well with the number of threatened species, it's not necessarily those species types that are that's on the brink of disappearing from fragments. And then lastly, what can be done to prevent predicted extinctions? Right, so my project for the last 5 years focused on forest fragments distributed from the Tugela River in the south all the way up to Lake Cozy in the north. So I surveyed birds within these fragments, I also surveyed trees, but most of the results in this talk will focus on birds. So to answer the first question, where are species going extinct? I try to come up with an approach where we can look at the whole landscape and model where are we most likely to lose species. So what I did was I surveyed birds and I tried to explain bird species richness per point using remotely sensed environmental variables. These variables included local predictors like biomass, forest cover, leaf area index, NDVI, forest texture, and then also a landscape variable called edge influence. So for every pixel in the landscape, I could source all of those variables. So therefore, I built a model to see if those variables predict bird species richness. It did. The model explained 52% of variation, which was the best that I could come up with. And I also think if we use core scale variables such as these that we can get from satellite images, that's not a bad model. All right, so now because I have those variables for every pixel in the landscape, I can predict bird species richness. Because you also have satellite images that go back till the early 90s, specifically 1991, you can theoretically see how bird species richness would change over time. So the example here is around Lake Cozy. I have a Landsat image that's from 1991. I have a Landsat image from 2015. I run my model over this image, and now I have predicted bird species richness per pixel. So a pixel in this case is a 50 by 50 meter block. As you can see, some areas in this fragment, species richness decreased. In other areas, species richness increased. But this is not so informative, but if I subtract these two rasters, it's a bit clearer. So you can see in this case, for this fragment, it seems that around the forest edges, we might have lost species, but around in the forest core, it seems to be stable or increase in species. If I then model this across the whole landscape, so the landscape's a bit big, so I just focus on this area. It's around the Duku forest, around Matuba. I couldn't really find a clear pattern of species gains or species losses, except, but you can see around a bit north of the Duku fragment, that small fragments embedded in plantations. It seems like the small fragments are losing species. It also seems your dune forest fragments around the edges, you might be losing species. I think what's worrying is, say, the Duku fragment that's in the center of this map, you're losing species in the core. There is some literature to say that this fragment is getting really degraded. So it looks like species losses are more a local process or local disturbances per fragment than a regional process driving overall losses and gains. I think what is interesting, if you look there in the bottom right, there's one fragment that seems to have really gained species over the last 50 years, and that is the Richards Bay dune mining. So that's where forests are being restored. So you probably started off there with a sand dune, ended up now with more acacia woodland with really high NDVI, and that's where that richness reflects. Right, so we've got a good idea where we are losing species. Do we know which species are the ones that are going extinct? So in fragmented landscapes, species colonization and probability of colonization and extinction is predicted by life history traits. So globally, insectivores and frugivores are the species most sensitive to fragmentation. You lose them first from fragments. Nectarivores, generalists, and granivores are relatively insensitive. Some of them also benefit from fragmentation. So using guilds as your life history traits to investigate presents a feasible option to see which species are sensitive and which are not. However, if you look at fragmentation or habitat loss, it's quite a complicated process. It's not just one single thing that happens with the landscape. So there's 3 steps. First, if you lose habitat, your habitat area decreases. You suddenly have fragments of different sizes. Another thing that happens is your habitat isolation increases. So your different fragments are now further apart than what they used to be. third thing is you suddenly have edge effects, and each fragment is also now exposed to a different matrix habitat. Where you just had forest, you now have forest adjacent sugarcane. So you have to consider this when looking at species responses to fragmentation. The other thing that you have to consider is there's abiotic variables that play a part. So you can imagine in our landscape, the north, you have this tropical temperate gradient. The north is maybe species richness is higher there, higher rainfall, warmer. Then in the south, you also have variations in topography. Species richness is higher in dune valleys than dune crests. So you have to take into account all of these different variables to unravel fragmentation effects. So what I did was I used a structural equation model. So I actually really need a pointer here. Is it? Oh, thank you. Thanks a lot. Got it. Right. So quickly. So what I asked was, okay, what affect bird diversity? So birds are affected by connectivity. It's got a direct effect on birds, but connectivity has also got a direct effect on trees. Matrix habitat has got a direct effect on birds. Area has got a direct effect on birds. Area has also got a direct effect on trees. Matrix habitat also has a direct effect on trees, but there's no ways I could get the model to fit if I include that pathway. Then also include latitude. Latitude's got a direct effect on trees and would therefore have an indirect effect on birds. Topography would have a direct effect on trees, indirect on birds. Climate, direct on trees, indirect on birds. So in my mind, this is how bird diversity is affected in our landscape. So the cool thing about this approach is you can develop the conceptual model and then you can test this model. And then it gives you a relative effect of each pathway, a relationship between each variable. So you can test each pathway. Right, so then I tested diversity in different guilds. So I started off with generalist feeders. So it's easy to interpret. So for example, if we look at connectivity, a 0.38 would mean connectivity, so 1.38. So generalist species would increase with connectivity, but it would decrease with area. And the effect size would be 1.03. Higher, stronger, lower, weaker. But what is interesting is not any one of these pathways are significant. So you have a strong effect size, however, it's not statistically significant. This whole model also explained 38% of variation in generalists and 65% in trees. Right? So it's a relatively good model for trees, not so good for generalists. If we then use the same model on different species guilds, granivores, we also see the same. We've got strong effects, none of them are significant. Same with nectarivores, strong effects, none of them significant. Frugivores, surprising, strong effects, but not a lot of variation is explained, so 20%. So this was surprising. We would expect frugivores to respond to fragmentation parameters. But the interesting one is insectivores. Right? So here we have significant effects. It's that insectivore diversity is affected directly by connectivity. So the more connected your habitats are, the more insectivores you have. It's also affected directly by trees, greater tree diversity, more insectivore diversity. But the interesting thing is, tree diversity in this case was affected by area. So you had area affected insectivore diversity indirectly through tree diversity. So if you have a larger fragment, you have more tree species and you have more insectivore species. Right, so from this we can conclude that the species that are most sensitive to fragmentation, the first ones that would probably disappear are your insectivores. Right, so now we come to the final question. So how do we protect it? What would be the best way to stop these species from disappearing? So the advantage that we have is just north of our borders in southern Mozambique. This is a picture of the Maputo Elephant Reserve. We have a relatively intact landscape that I imagine most of KZN looked like 150, 200 years ago. So we can see what happens in this landscape and try to use what we find there on our landscape. So what we did was we surveyed birds in 30 fragments in southern Mozambique, surrounded by natural grasslands and woodlands. And we surveyed birds in 30 fragments in KZN that's surrounded by the sugarcane plantations. And we looked at species-area relationships. So we would expect more species in larger fragments in both landscapes. We looked at specialist species and generalist species. So what we found was that in the transformed landscape, we only found a species-area relationship for specialist species. So in small fragments, in a transformed landscape, you have few species. Large fragments, you have many species, just specialists. There was no relationship between generalists. In the natural landscape, if you don't have transformed habitats, you find no species-area relationship. So even for specialist species, you find the same number of specialist species in a small fragment than what you would find in a large fragment, which suggests that for birds, even though the habitat looks fragmented to us, it's not. They utilize these natural matrices. When we then run occupancy modeling on species-specific for each species, so we'd expect a significant occupancy model to be species would be present in large fragments, but absent in small fragments. When we run that per species, we see that for forest specialists in a transformed matrix, all of these species were significantly affected by area. These two were not, but you don't find that with generalists in a natural matrix or generalist species. You don't find it for specialists in a natural matrix or generalists in a transformed matrix. So again, you have strong area effects when the matrix is transformed. Right, so in conclusion, species losses are haphazardly distributed. There's not really a pattern which suggests it's local disturbances driving this. Forest insectivores are particularly sensitive to forest loss and fragmentation. But I suggest that the way that we can halt this is by including matrix habitats when we focused on forest conservation. Matrix habitats may play an important role in safeguarding diversity in this naturally fragmented landscape. So thank you very much.